Hello and welcome to the Physics Live program. I am your online physics tutor bedprakash. We are discussing about fluid mechanics. Let's learn. Hello and welcome to my channel of contemporary science educational video. Please subscribe the channel to show your love and support by pressing the bell icon for latest updates. Thank you. Hello, this is the fourth online physics session on fluid mechanics. In this session, I am going to discuss with you the continuity equation for fluid. So let's have a look on this. The continuity equation of fluid mainly works on the principle of conservation law of mass. The principle states that mass can neither be created nor be destroyed. Likewise, the fluid flows in a conduction material abiding by this law. So let's have a look on the board how the conservation law of mass applied on the continuity equation, and it forms the equation of continuity as a result. Let's understand continuity equation here. To understand the continuity, we have to consider the fluid be in steady flow. That means the fluid has a constant velocity with time. Let's consider a pipe of varies cross section like this. Here the fluid is entering from this side and it is exiting in this direction. Consider that here the cross-sectional area through which the fluid is getting entered is say A1, and we are choosing a section of length L1. This is say section 1 having the length distance of L1, and we are choosing a section in this outlet section of length say L2. Now this cross-sectional area through which the fluid is getting exit, let's consider is as A2. This second section consider a velocity of v2, and for this first section consider the velocity of say v1. The fluid is flowing in this direction and it is getting exit over here. Now we have to consider that the flow rate of fluid, the amount of volume it is passing in unit time. The volume displacement is shown as this for this particular section 1. The fluid is taking t time to pass this section with volume is v1. This volume can be written in the form of cross-sectional area into length by time. Now this length by time term is actually the fluid displaced in unit time, that is the velocity of the fluid in this section, that is v1. Consider this section that the fluid is taking also t amount of time to pass this section in outlet. The flow rate for this particular section will be q2 as amount of volume passing in this particular time. Now likewise in the input section, the volume can be written as cross-sectional area as A2 into the length by unit time. Now this term is again transforming in the form of V2. Since it is a single pipe and the fluid is flowing with steady flow, so we can consider that the fluid is having same amount of flow rate, that is q1 equal to q2, that is q1 equal to q2. Now for this particular reason it can be written as a1b1 equal to a2v2. This equation is basically termed as continuity equation. So this is all about the continuity equation. Now where it is getting applied, we have already noticed that whenever you are trying to wash your car or wash your bike, then we often use a pipe to attach it with our available tap, and we keep forcing it in the to wash the car or to gardening the flower trees, etc. So in this particular application, we have noticed that whenever we are pushing the tap, the pipe is exhibiting a very very small amount of cross-sectional flow with greater velocity due to this continuity equation. It can also be understand in the case of hydrant, that is the watering instrument installed beside the street. So let's have a look on this. So we have understood the continuity equation formulation. Now we are interested to know about the different application in the real world. So as I have explained already, the in the case of gardening as well as in the case of car washing or different kind of remote application type cases, we attach some pipe and we change the velocity of the fluid by tapping the pipe in its opening end. Now let's have a look on the condition of the continuity equations. Now as you can see that fluid condition should be non-viscous fluid as well as that is incompressible in nature. In this particular cases regarding the compressible and incompressible fluid, I will discuss in my another session. Now you have to understand that for maintaining the continuity equation, the fluid should obtain some specific defined condition like non-viscous liquid and streamline flow as well as steady flow and incompressible fluid as well as the volume flux of the fluid should be is in its constant nature. These are the some condition where the continuity equation sustains, like the velocity will increase if the cross-sectional area decreases. It is quite obvious. I have already told you the example of tap tap water, as well as you can see in the behind of me that an picture of hydrant has been shown over here. Basically I will show you the calculation of hydrant a little later, considering the waterfall from tap as well as in the hilly region, especially in hilly region, the narrow or shallow flow of small cross-sectional area can be seen with faster velocity. So these are the some special case you have to commemorate for your entrance exam, as I give you some tricks in each of my sessions. So in this particular session I will give you the tricks for commemorate these points, these 4 points, to which from which you will get the help of this. Now I think sometimes a very common question regarding the hydrant comes from this particular section. So let's have a look on this. Here is a picture of a hydrant. As I was discussing that we have to understand the calculation part of the numericals related to this kind of hydrant. So let's have a look. The hydrant has a nozzle part starting with, say, cross-sectional area of A1 and velocity of V1, with which the fluid or the water is leaving the hydrant nozzle. Now the pipe ending has a different cross-sectional area of A2 and different velocity of V2. Now, from the continuity equation, we all know that Q1 equal to Q2, that means A1 V1 equal to A2 V2. The hydrant is also circular in nature, so it will have the cross-sectional area of pi r square, that to be very specific r1, where r1 is the radius of the hydrant nozzle, and v1 a2, that is the cross-sectional area of the pipe opening, is pi r2 square, where r2 is the radius of the pipe diameter. The velocity is v2 at the pi. Now the pi is getting cancelled out. So if we want to know about v2, then it is sometimes asked that what will be the velocity of the water at the end of the pipe. So for that particular purpose, we require V2 equal to R1 by R2 whole square into V1. This kind of formula is also applicable whenever you are asked that with how much velocity the fluid is leaving the hydrant nozzle. In this case, V1 is known. In the case where V1 is unknown, then we require the formula of V1 equal to, here it will be more convenient, V1 equal to R2 by R1 square, just opposite this, R2 by R1 square into V2. These type of formulas are very useful at the time of solving your problems in your entrance exams. Let's have a look on the different fluid energy and its form of formulation. I am discussing about the different kind of fluid energy. There are three types of fluid energy about which we have to get concerned of. Now, one is pressure energy of the fluid, another is static energy of the fluid, and another other is kinetic energy of the fluid. The pressure energy of the fluid is basically the pressure processed by the fluid per unit mass. For the calculation of static or potential energy of the fluid, it is the rho gh. As you can see in the presentation behind that, it is basically the rho gh of the fluid. Now for the calculation of kinetic energy, it is half rho v square, basically the energy possessed by the liquid by virtue of which the fluid achieves its velocity. That's all about the continuity equation and related topics of fluids. So that's all for this session. Thank you for watching my session. Be in my channel for lecture series. Thanks for watching. Thank you.